We just have seen how to solve systems of linear equations, and now we are going to expand this technique a little bit more to see how to apply it to calculate the inverse of a matrix. So let's suppose we start with a matrix A whose components are A11, A12, A21, A22. And we want to right multiply it by a matrix that we will call A minus 1, whose components will be, well, let's call this matrix B, whose components are B11, B12, B21, B22, such that AB equals the identity matrix, which will be 1, 0, 0, 1, and in this case we will call B A minus 1 if it satisfies this condition. So how do we do this? Well, we have to solve a system of equations which involves these four incognitas. So let's look at the following. To solve this, we have to multiply this row by this column, and we obtain A11, B11 plus A12, B21 equals 1. Now the same with the second one, second row. With the first column still, we obtain A21, B11 plus A22, B21, and in this case equals 0. I'm looking at this element and this element. Fine, and notice that this is a system of equations for the incognitas B11 and B21, so we can write it as before as A11, A21, B11 plus A12, A22, B21 equals 1, 0. And this is exactly a system of equations as we saw in the previous lecture. So we can transform it right as before to the following expression: A11, E1 plus A21, E2, B11 plus A11, no, yes, plus A22, 2, B21 equals E1, because this is exactly the second equation. And we are going to coin this term R1, and we are going to coin this term R2, so we can write the equation as R1, B11 plus R2, B21 equals E1. And we know how to solve this equation from the previous lecture by right multiplying by left multiplying by R1, so we obtain R1, R2, B21 equals R1 wedge E1, and similarly the other way around, R1, R2, B11 equals E1 wedged R2, and therefore we can immediately obtain that B21 equals R1 wedge R2 minus 1, R1 wedge E1, no, well yes, but I wanted to put this one second for organizational purposes. You will see why in a bit. And B11 equals R1 wedge R2 minus 1, E1 wedge R2. And we can repeat the same strategy for the first, again, the first row with the second column. which will be A11, B12, I had 2, 1 here, yes, right, plus A12, B22, and this equals 0, and A21, B2, B12, plus A22, B21, 22, yes, equals 1. Okay, A11, A12, B, yeah, okay. So I did this equation, if I did not do any mistake, is the one marked in red, and then I did this multiplication times this multiplication again. I'm going to erase this for not confusing. And obtaining this system of equations, which we can write right as before as R1, as defined up here, B12 plus R2, B22 equals E2 in this case. This is what we have in here. Thus, the solution, we can follow the same steps as before and get that B12 equals R1 wedge R2 minus 1. And here we have E2 wedge R2, and B22 equals R1 wedge R2 minus 1 equals R1. No, not equal. This equal is mistake. R1 wedge E2. And with this we can find the coefficients of our matrices, which we can write, if we want, in a matrix form as B, which equals, is coined A minus 1, equals 1 divided by R1, R2. Let's write it this way. And in components we have E1, R2, R1, E1, E2, R2, R1, E2. And this is our inverse matrix. So let's check that this is the case by calculating an example.